When it comes to volume of a prism, really all we're doing is adding one step to what we did yesterday. The volume, of course, is the capacity. Instead of the surface area, how much can fit inside? We use volume all the time, milk cartons, beverage containers, things like that. How much capacity do they have? That's what we're measuring as volume. Volume, it should be noted, is always measured in units cubed, or cubic units. And we'll see why in just a second. But there's only one formula that we really have to worry about, and that is for a prism, volume is simply base area times height. And guess what? We've already calculated both those measurements yesterday. We calculated the base area, we calculated the height. All we're going to do now is combine these two multiplied to give us a volume. However, you'll notice that the base area is always going to be, since the perimeter is a length, centimeters, the height is a length, centimeters, base area is an area, centimeters squared, lateral area is an area. But if I multiply a centimeter times a centimeter squared, I'm going to get centimeters cubed. And volume is measured in units cubed. So it's consistent. With any rectangular-based prism, we always have the little additional challenge of defining what is my base. Again, I'm going to just go with the easiest thing and use the bottom. I've got them already shaded. So the base, the perimeter of that base is 10 plus 4, 14, 24, 28. If we trace our way around, 28 centimeters. Height is the distance between the bases, which is 6 centimeters. The base area is a rectangle. 10 times 4 is 40. The lateral area is the perimeter of the base times the height, 28 times 6. Or 168 centimeters squared. My total area is my lateral area plus 2 bases. So if I do that, that's 248 centimeters squared. And finally, my volume is the base area times the height, 40 times 6, or 240 centimeters cubed. That means I could fit if this is actually drawn to scale, I could actually fit 240 little cubes in here that are 1 centimeter on each side. That's how many would fit, exactly 240. So there we are. Now, some people say, well, that's great, but what if I'd have picked what if I'd have chosen this right side as my base instead of the top and bottom? What if I chose those as my bases? Are my numbers going to come out different? Well, yes, they are. Let's see how different. Perimeter of the base is now 4 plus 6 plus 4 plus 6 or 20 centimeters. The height is the distance between the bases. That switches to 10 centimeters. The base area, 6 times 4, is 24 centimeters squared. The lateral area is the perimeter of the base times height. 20 times 10 is 200 centimeters squared. The total area is the lateral area plus 2 bases, so 200 plus 48. Oh, now we're the same again, aren't we? And the volume is the base area times the height. 24 times 10 is 240 centimeters cubed. So even though these intermediate numbers, the perimeter, the height, the base area, the lateral area, are all going to be different depending on which base we choose, the total area and the volume should be exactly the same. Total surface area and the volume. Believe me, when it comes to tests and quizzes, I will have it figured out every possible way so that you will get full credit if you do one of the ways correctly. Remember, though, we can only switch base sides if we're using a box. If it is a triangular prism or a hexagon or a trapezoid prism or anything like that, I can't just randomly switch what my base is anymore. Now we're fixed. Here we got a cylinder. Same types of problems. Radius of the base is 4. So perimeter of the base would be pi times diameter, or 8 pi. And again, I'm going to pre-fill in my units here. So I know I've got them, correct? I don't want to forget them. Height is the distance between bases is 12 inches. Base area, pi r squared. Once the radius is 4, that's 16 pi inches squared. Lateral area is the perimeter of the base times the height. 8 pi times 12 is 96 pi inches squared. Total area is lateral area plus 2 bases. That's 32 plus 91 are 128 pi inches squared. And volume is base area times height. 16 times 8 is 144 pi cubic inches. Or square inches. Sorry, I just switched up the total area. I just switched something up. Hold on, let me go back. Total area is a lateral area plus 2 bases, so that's 32 plus 96, 120, 128 pi. Volume is base area times height. There we go. I did perimeter of the base times height. That was my bad. Base area times height, which would be 16 pi times 12, 192 pi cubic inches. So again, setting these things up, following my formulas. Base area times height. Lateral area plus 2 bases, perimeter of the base times the height. All right, very important that we know these formulas and are able to use them. Sometimes we get compound figures, but it's really not that any more difficult to work with. Here, it's still the same basic formulas. The non-rectangular shape is my base, so this kind of L-shaped thing is my base. I'm going to have to do a little figuring with the perimeter. If this is 3 right here and this is 3 here, that means this opposite side has to be 6. If I use 15 here and 10 of it here, that's got to be 5 centimeters across there. So the perimeter of my base is going to be 6 plus 5, which is 11, plus 3, which is 14, plus 10, which is 24, plus 3 more, 27, plus 15 would be 42 centimeters. The height is the distance between the bases. So right there, 5 centimeters. The base area, a little bit tricky, but not bad because it's rectangles. Again, if this is my base, I'm going to break into 2 areas. First one, this one here, which is 10 by 3 or 30. Plus the area here, which is 6 by 5, which is also 30. So 60 centimeters squared. Lateral area is perimeter of the base times height. 42 times 5 is 210. Total surface area is lateral area plus 2 bases, so 210 plus 120 is 330. Sorry, a little carried away there. And my volume is the base area 60 times the height 5. 6 times 5 is 300 centimeters cubed. So again, it doesn't matter the shape. If it's a little irregular, we just still work with it. Same basic idea. Well, it's 2 bases are the same. It gets more interesting when we start combining figures, either through addition or subtraction, to find area and volume, surface area and volume. This is a pretty complicated figure, actually, because we've got this base area right here. We've got the lateral area of the box, so the 4 sides of that box. On top here, I have a square minus a circle, but I'm going to add that circle back in. So really, I've got a second base there. And then the last thing is the lateral area of that prism. So the total surface area is the lateral area of the bottom plus the lateral area of the top plus 2 base areas of the square. Lateral area of the bottom is going to be perimeter of the base. The base is a square, so 6 times 6, or 6 plus 6 plus 6 plus 6 is 24. Perimeter of the base is 24 inches. The height is 12. So the lateral area is 24 times 12, or 288. Lateral area of the top, if my diameter is going to be 6, my radius is 3. So the sorry, the 288 down there. There we go. So the lateral area of the top, perimeter of the base would be 6 pi. Pi times diameter. The height is 10 centimeters. So the lateral area is perimeter of the base times the height, or 60 pi centimeters squared. The base area, the base of the square, 6 times 6 is 36. There are 2 of them. That makes 72, excuse me. We simply add those all up. 288 plus 60 plus 72. And that'll give us our total surface area. If we add those up, it's 290 plus 60 is 350 plus 70 is 420, I believe, centimeters squared. Would be my total surface area. Find the volume of this would be it's simply add the 2 volumes, volume of the square-based prism plus the volume of the cylinder. There are a lot more types of problems we can do. Which has more volume? If I take a piece of paper and wrap it up the long way or the short way, do I get the same volume from both pieces of paper? In fact, I'm going to let you work on this as your daily check. It's kind of a complicated issue. I'll tell you this much, the volumes are not exactly the same. You may think they are, but they are not, and I want you to calculate both volumes. For the one way, the circumference is 11 inches, the height is 8.5. The other circumference is 8.5, and the height is 11. Find the volumes of those 2 cylinders formed by wrapping a piece of paper, one the long way, one the short way. Those volumes should be different. And we'll get problems like this that have holes in them. What's the surface area and volume of this? The problems can get rather complex. So it's stuff to think about. Certainly I'll be there to help you with this as well. So be sure to ask questions if you need to. These problems will take a little time. They'll take a little thought. They're definitely puzzle-solving problems here. For example, if I define the surface area and the volume of this, well, the volume actually isn't bad. It's the volume of the big cylinder minus the volume of the small cylinder. That's easy. The surface area is going to be a bit more complicated because I have to take the surface area of the entire big cylinder minus the 2 holes there, top and bottom, in the surface, but we'd have to add in all the surface on the inside of this cylinder cutting through the inside. So we'd have the lateral area of the small cylinder added to the total area of the large cylinder and subtract from that the area of those 2 small circles cut in the top and bottom. So it can get complicated. All right. Basically, quick summary, the only new formula we have is total volume is base area times height. The rest of it is all variations on that. So see you in class.